And to our final presentation now, Generation AI-driven closed-loop automation management. That's a little bit of a mouthful, isn't it? But we have Marvin Fang, the Deputy Director for Global OSS Solutions from Whale Cloud International. Martin Fang is responsible for Whale Cloud's OSS marketing strategy and business development. With rich experience in product planning and marketing in core network, managed services, MANO, and OSS, Marvin is supporting global telcos to identify, plan, and execute successful digital OSS transformations. So let's welcome Martin and listen to his presentation. Hi, Martin.
Thank you, Henry. Ladies and gentlemen, dear friends and audience present and around the world, good morning, good afternoon, and good evening. This is Marvin Fang from Nanjing, China, and I'm the Deputy Director of Whale Cloud International Global OSS Solution Team. It's a great honor and pleasure for me, myself, and Whale Cloud to have this opportunity to share our views and experiences on the autonomous network management. As a professional OSS vendor, my topic today is about the digital OSS transformation and how do we try to enable the autonomous network with AI-driven closed-loop automation. Firstly, I'll briefly analyze the trends and challenges of the current telco industry. Then I'll give our suggestions for the OSS transformation. Next, I shall share our Whale Cloud digital OSS architecture and especially our AI capability. And finally, I'll use two typical use cases to show you how the digital OSS works in the autonomous network. As we know, the telco industry has undergone tremendous and disruptive changes and transformations, especially for the past few years. New kinds of network and the technologies has emerged ever since especially since the coming of the SD and AFV. And with the coming of 5G, various and diverse services have also been possible. And the ecosystem based on network has also been greatly broadened. The prosperity of the new technologies, network, and services have, of course, made the communication world more colorful and promising, and have also created more opportunities. On the other hand, however, the changes also have created more challenges for the industry. For example, how to manage the hybrid network with both the legacy physical network and the virtualized or cloud-native one. How to realize the cross-domain and cross-layer orchestration, management, and display. How to sharpen TTM of the new services. How to open the capability of the network and the whole system to partners to catalyze the new scenarios and new services. How to transform the organization and culture to better match the technical changes. And how does a CSP transform to a DSP, digital service provider, and DSC, digital service collaborator? So it's rather important, rather difficult to face and deal with all of these challenges and changes. And among all the ways and methods to solve this problem, to build an autonomous network has been a consensus and common concern. As an enabling and supporting system, OSS has played a vitally important role in building the autonomous network. And with the introduction of the new technologies, we obviously view the incompetence of the legacy OSS. So it's a must to make the OSS transformation. There are many features and capabilities the new digital OSS shall consider and include. And some of the most important key points are the new digital OSS shall become an end-to-end unified orchestration center for the hybrid network, supporting cross-layer and cross-domain collaboration, correlation, and orchestrations. It also shall include the AI capability and automation capability, and it's better to merge them. Also, it shall be able to open the capability of itself to the third-party systems or partners more easily, in a standard way. Also, the new digital OSS shall support the new popular technologies like the SBA architecture, the DevOps, the CI/CD microservices, etc. Since it's an all-round change for the OSS, we think it's more appropriate and practical to make the transformation step by step, with at least two major milestones towards the future OSS. The first step, when the legacy CSP introduces the virtualization technology in the network and tries to evolve to a DSP, digital service provider, it's a must to enhance the legacy OSS system to be able to manage the hybrid network. And now, the new OSS shall become an orchestration and management center for both the legacy network and the virtualized one. And the second step, when a DSP tries to enlarge the ecosystem with partners and tries to evolve to a DSC, digital service collaborator, the OSS shall become more agile and intelligent. And AI capabilities and closed-loop automation capabilities shall be introduced for the OSS at this stage. To cope with these challenges and requirements, and based on our rich experience in this industry, WeCloud has also been transforming the OSS system these years. Here is a brief introduction of our WeCloud digital OSS architecture. What we plan to do is to provide a system which is open and having the cutting-edge technologies. And all the system has now been cloud native, and modules have been pre-integrated in the OOTP way. We've also developed multiple mobile apps for different scenarios and different users. For example, the field survey engineer, the field installation engineer, etc. So it's a system focusing on the efficiency, costs, new technology, and also the experience of different users and roles involved in this system. And for the architecture, as you can see, the system can be divided into 4 domains according to the lifecycle of the network and the service. And the first domain, strategy, infrastructure, and product, mainly focuses on the plan and design of the service and network. Here, the SCM, Service Catalog Management, builds the service model from CFS to IFS and finally resource, which can be used for the so-called catalog-driven service orchestration. And A-Design is used for the network plan and design, including the fixed and radio access network, ISP, OSP, high-level design, and low-level design, as well as the end-to-end rollout management. For readiness domain, one important module is RRM, Resource Inventory Management, which is used for the lifecycle management of the hybrid resources of the whole network. And also it supports the measurement and clear display of the cross-domain and cross-layer resource topology. For fulfillment, one important module is SOM, Service Order Management, which acts as the end-to-end unified orchestration and management center for the hybrid network and the diverse services. For example, the network slicing services. And for assurance, I'd like to mention 2 modules: the KDO, Knowledge-Defined Operation, our AI center, and the CLOM, the Closed Loop Automation Management Center. And later I'll show you how they work together to build the AI-driven closed loop automation capability. Also, we have many distinctive public modules. For example, the GIS platform, which allows the users to easily design, view, and operate resources directly on the GIS map. And BizSDK, which makes it much easier for the DSP and DSC to design the new services if they want. The modules in different domains actually almost never work independently, but collaborate together to form 3 major capabilities. 1, the service and network design and rollout management. 2, end-to-end hybrid service orchestration. And 3, AI-driven closed-loop automation, which is a must for the autonomous network. The importance of AI in the autonomous network is self-evident. So WeCloud has also been enhancing its AI capability these years. And here's a brief introduction of our AI solution, KDO, Knowledge-Defined Operation. On the bottom, KDO provides an open platform to integrate with the AI-related frameworks. And above, KDO composes of two layers, the function layer and the application layer. The function layer includes the core capabilities of the solution. Firstly, here, the component management module is responsible for the management of the AI components, such as their component development, the component registration, etc. And based on the components developed here, the module development here can generate and form the AI operation models, and the lifecycle of which will be managed here, the module management module. Scenario is an instance or runtime view of the operation model. And also we have another module called recipe generation, and it's still under planning. What we plan to do is to generate the recipes manually or automatically based on the rules, scripts, and policies. With the capability of the function layer, we can form rich applications. And based on our experience and practice, we have launched multiple applications in different scenarios. For example, we support cross-domain and cross-layer fault locating and visualizations, and the auto-dispatch of the work order to the most appropriate engineer based on multi-dimensional factors. In this way, we can greatly improve the fault handling efficiency and help to meet the SLA. Dynamic threshold and anomaly detection and the multi-dimensional prediction provides proactive care to improve the network quality and the customer experience with multiple methods. For example, the anti-shake rules, the KPI trend prediction, the capacity prediction, etc. We've also introduced machine learning for the alarm management. For example, the machine learning-driven rule mining for the alarm compression, self-healing, the RCA, etc., which will further improve the automation degree and intelligence of the network. Next are two typical use cases. The first case is about the zero-touch orchestration of the network slicing services. Network slicing has been a very hot topic in recent years, and we think the zero-touch orchestration for network slicing shall be one focus of the future digital OSS. The main process for this case is, firstly, as a precondition, the SCM, Service Catalog Management, will synchronize the NSST and NSD from the NSSMF. And then, when detecting a network slice failure, the OFM, Operation Flow Management, will send the change request to the SOM here, Service Order Management, to create or modify a network slice. And the SOM acts as an end-to-end unified service orchestration center. Will conduct the network slice orchestration into network slice subnet instances, and with the collaboration of other modules like the SIM, the ROM, the provisioning, which will conduct the following activities like the resource assignment, the network and service activation, etc. The SOM will complete the creation of the new network slice. And after the onboarding of the network slice, the modules in assurance domain will keep monitoring it. For example, the FM, fault management, will keep monitoring the alarm data of the slice, and the PM, performance state management, will keep monitoring the performance data of the slice. And the AI Center, or KDO in our solution, will provide the AI capability to enhance the monitoring. For example, the fault prediction, the alarm correlation rules mining, the performance prediction, etc. And also the SLM here, the service level management, will keep analyzing the alarm data and performance data as well. And once the service level degradation is perceived, the SLM will trigger the OFM to send the change request to the SLM to conduct the service orchestration and to meet the SLA again. So in this case, you can find that the system synchronizes both the orchestration domain and the assurance domain. And with the introduction of the AI capability and the closed-loop automation, we can realize zero-touch orchestration for the network slicing services and, of course, other kinds of services. The next use case is about AI-driven automatic automatic closed-loop assurance. It mainly focuses on how to build the closed-loop automatic operation to improve the operational efficiency, quality, and costs. The CLAM Center here, the Closed-Loop Automation Management Center, keeps monitoring the events from the southbound systems like the RIM, FM, PM, SLM, etc. For example, the FM will keep collecting the alarm data from the southbound systems and then use the alarm correlation rules learned by AI from the AI center, and the FM will generate alarm events and send the events to the CLAM center. And PM will keep monitoring the performance data and use the latest performance prediction result from the AI center and generate the performance events and send the event to the CLAM center. After collecting these events, the CLAM center will, based on the pre-configured policies from the policy base, auto conduct the event analysis and policy decisions. There are different kinds of decisions. If the parameter configuration or modification of a specific network element shall be done, the diagnosis system will be triggered to conduct the commands to the network element directly or indirectly. If the lifecycle management action of a service instance shall be done, the CLAM center will tell the SOM to conduct the service orchestration, just like the first use case. If the field handling tasks or the preventive tasks shall be done, the CLAM center will tell the workforce management, which will automatically dispatch the tasks to the most appropriate engineer based on the predefined roles and collaborate with the mobile apps installed in the field engineer's mobile phone to complete the field task handling. So, with this AI-driven closed-loop automatic assurance solution, we can maximize the system efficiency and minimize the manual intervention. So that's all for today's sharing. WeCloud has been working in the OSS industry for many years, and we sincerely hope we can collaborate together to face and deal with the challenges together and make the communication work better. Thank you all for your time. Please feel free to contact us. You can visit our Business Online website, where you can visit our latest solutions, products, talk with us, and even try out our products directly online. That's all. Dear friends and audience, distinguished host Mr. Henry, MWC21, thank you all again.